welcome back to the channel. So in today's video we are going to understand SwissADME, one of the most powerful and widely used tools for predicting drug likeliness and ADME properties of small molecules. So if you are working in molecular docking, drug discovery, medicinal chemistry, pharmacology or computational biology, so this video is extremely important for you. So let's get started. So first, let's try to understand what is SwissADME. So it's a free web-based tool developed by Swiss Institute of Bioinformatics. If it predicts absorption, distribution, metabolism, excretion, drug likeliness and medicinal chemistry properties. So it is mainly used for molecular docking to evaluate whether your compound can actually be a drug or not. So now let's look at the demo part. So you can search SwissADME in the Google console and land over here. So fill with the smiles format, or you can copy paste the smiles format of your molecule of interest. Okay. Then click on run. So this tool, as I mentioned before, it will give information about the physicochemical properties. It talks about the total number of atoms present in the molecule and its molecular weight, that is 206.28 grams per mole. For any drug molecule to become an oral drug, its molecular weight should be less than 500, and this is satisfying the condition. And high molecular weight reduces the membrane permeability. Okay. And if we look at the number of hydrogen bond donors and acceptors, here we have one donor and two acceptors. So in accordance with the Lipinski Rule of Five, number of hydrogen bond donors should be less than or equal to 5 and acceptor should be less than or equal to 10. So if you see the rotatable bonds, here we have 4. It should be always less than or equal to 10. If there are too many rotatable bonds, the flexibility of the molecule will reduces its overall availability. And coming to the other aspects here, so we are looking at total polar surface area, and this value should be less than 140 angstroms. Okay, so it indicates a good oral absorption. And if it is less than 90 angstroms, so any molecule, if you are targeting for neurological problems or if you are treating the nervous system, so then the TPSA value should be less than 90. Okay, that gives good penetration to the with the blood brain barrier. And coming to the lipophilicity, so here we have a consensus LogP value which talks about the lipophilicity, and it should be always between 1 and 3. So that is the ideal range. If it is greater than 5, it may indicate pure solubility, and if it is 0, it indicates there is no membrane permeability for this molecule. And coming to the water solubility, it is given by 3 tools, ESOL, Ali and Silicose IT. And you can see here the values for the log S, it should be greater than 0. It is highly soluble, and if it is between -2 and 0, it is soluble, and -4 and -2 is moderately soluble, and -6 is insoluble. Here the value is between -3.36. It means the molecule is moderately soluble. And coming to the pharmacokinetic properties, you can see here the GI absorption is predicted as high. Okay, so high GI absorption indicates it can be used as a oral drug molecule, and it is a BBB permeant. It means it indicates the molecule can cross the blood-brain barrier. So this drug molecule can be used for targeting the diseases or disorders related to nervous system. So on the other side, it could be a cross target or off target if you are targeting some other organ of our body. So here the main thing is that PGP substrate. If any molecule, if any small molecule, if it is a non-PGP substrate, it means it can cross the blood-brain barrier. If it is a PGP substrate, it can be easily pumped out of the cells and reducing its bioavailability. And here we have cytochrome P450 inhibition. So for all the molecules it is known, if the compound or the small molecule is targeting or inhibiting these enzymes, it may cause drug-drug interactions. So coming to the drug likeliness, so this molecule is satisfying the Lipinski Rule of Five. It means the molecular weight should be less than 500, number of hydrogen bond donors should be less than 5, number of hydrogen bond acceptors should be less than 10, and lipophilicity should be less than 5. So if the molecule is satisfying all these four conditions, it means it is following the Lipinski Rule of Five. And we have the other rules, Goose rule, Weber rule, and Egan rule, and McGill rule. So all these rules talks about the TPSA values or the molecular weight, and all the conditions are satisfied for this molecule. And there are some medicinal chemistry alerts which are being shown here. So we have pain alerts, you can see there are 0 alerts, and Brenk alerts, and it is also 0. So these two alerts indicate the false positives or potential false positives and structural fragments associated with the toxicity. And if you look at the lead likeliness, there is one violation. The molecular weight is less than 250. And to conclude, it's like before proceeding for any molecule to cross-check as a drug molecule, to confirm it as a drug, so we need to do the analysis using SwissADME. So particularly we need to check the Lipinski Rule of Five, evaluate LogP values and TPSA, confirm the GI absorption. So if the molecule is inhibiting CYP, then the molecule has to be avoided, and ensure there are no pain alerts. So SwissADME is an essential step after or before docking for experimental validation. So thank you for watching.